The best place to start is with a single vision lens. We will process multifocal jobs later in the video. The first step in doing a single vision job is to trace the frame. The most important thing in tracing a frame is to remove both lenses, clear the frame from dirt, glass beads, and debris, and check to make sure that the barrel screws are tight. This can avoid any problem with the tracer. It is preferable to hold the frame by both temples to give you better control. Gently slide the front slider open on the tracer. Carefully position the frame between the upper and lower frame retainer pins. Release the slider and confirm that the frame is between all retainer pins. Once the frame is in place, there is no need to further adjust, center, or secure the frame. Next, press the center trace key. The rim retainers will secure the frame without distorting its shape, and the stylus will automatically engage into the eye wire. After tracing one side, it will automatically trace the other side. This tracing technology digitizes an unprecedented 32,000 points of data, the circumference, shape, frame PD, and frame curve, to provide a perfect lens fit into today's most difficult frames. When tracing is complete, the stylus will return to its home position. The rim retainers will open, and the light on the trace key will stay lit. At this point, we can remove the frame. Press Data Set. This brings the frame down from the tracer into the control panel's memory. The RISC microprocessor utilizes an exclusive SuperFit software to calculate the frame data. Notice that the LCD screen displays an exact 1-to-1 size of the frame just traced. Now, before the lens is cut, a few parameters must be set. At the top of the screen, you will notice that the frame PD field has already been filled. The PD field is already highlighted, prompting you to enter the patient's distance PD. Pressing the plus key will automatically enter the default value, usually 62.0. You may change this value to match the patient's distance PD by simply pressing the plus or minus keys. The LE9000 will automatically subtract the patient's PD from the frame's PD and decenter the lens accordingly. The layout display will show you the decentered position of the optical center of the lens as it will look when completed. If you change the PD, the position of the optical center will automatically adjust to show you the change. I'm going to enter a PD of 66 millimeters. If vertical decentration is required, you can do this by pressing the down arrow key. This and size will be discussed later in the video. Now confirm that ACT is selected in the Layout Mode field. The next step in completing a single vision job is to set the lens and frame materials. This will assist the machine in determining the proper grinding sequence and size of the finished lens. By pressing the lens key, you will cycle through our lens selection frame materials to match the job, metal, xyle, or rimless. For this frame, it is metal. The mode key is used to select the desired grinding mode. The LE9000 is equipped with an automatic bevel location system with an option to manually control and calculate the ideal bevel curve for the traced frame. Our 3D SuperFit software assures the operator of a perfect frame curve bevel fit on any and all types of lens and frames. Using a lens meter, spot the optical center on both lenses. Place the spotted lens on the CE1 blocker support tips. Ensure that the decentration slide is at 0 or on center. Align the optical center of the lens with the 0 center of the blocker grid. With a block and leap tape in the blocking arm, block the lens. Remove the blocked lens. Now we are going to grind our lens. Place the blocked lens into the block adapter of the grinding chamber and press the chuck key. The chuck clamp will move in to secure the lens. Press the start key to initiate the grinding sequence. The LE9000 will map the lens for sizing and bevel location. If the lens blank is too small to cut out, the cycle will be interrupted and the display will indicate which part of the lens won't cut out. This saves a lot of time and eliminates spoilage. The front surface is also measured. This determines the lens base curve and lens edge thickness. The edge thickness will be used along with the frame curve measured by the tracer for determining the automatic bevel location. When the wheel starts out, the water comes out. Make sure the nozzles are aiming in the right place. Careful adjustment will allow water to hit the inside of the lens and around the grinding surface without splashing. When the grinding cycle is complete, the lens will raise and the diamond wheels will come up to stop. Press the chuck key to open the chuck and remove the lens. A perfect fit every time. Doing a multifocal lens is similar to grinding a single vision lens. But first, we must recognize the differences between various multifocal lenses. For this demonstration, we'll show you the three most popular styles: bifocal, progressive, and executive lenses. The next job is a bifocal lens. Bifocal types include flat tops, round top, round segs, and trifocals. As you can see, there are many different types of bifocal lenses, yet we will use the same blocking method for each. For this example, we will use a flat top bifocal. We will trace a frame just as we did previously on a single vision job. Press Data Set. After the shape comes up on the display screen, you must enter the patient's near PD into the PD field. For bifocal lenses, it is necessary to adjust the height of the segment. Highlight this field by pressing the down arrow key. The vertical decentration field adjusts the vertical layout for multifocal lenses. The LE9000 can use 3 different layout methods depending on the type of multifocal lens you're grinding. You can switch between each layout method by pressing the Select key. For the flat top bifocals, we use the BT layout. It's used for vertical decentration measured from the bottom of the frame to the top of the bifocal segment. This is the most common method of measuring the location of the bifocal seg. The LE9000 automatically enters 1/2 of the frame's B dimension into this field by default. Press the plus or minus keys to raise or lower the bifocal height to match that of the prescription. Press the down arrow key twice to highlight the layout method. Press the Select key until the BF method is selected. The BF method will automatically decenter the lens 5 mm up and 5 mm out from the center of the frame to keep the block adapter and chuck away from the edge of the lens. This ensures that they will not touch the grinding wheels, especially on small frames. When using the BF layout method, you must account for the 5 up and 5 out offset. The CE1 blocker has a bifocal seg preset to 5 in, 5 down, especially for this purpose. Align the seg of the bifocal lens with the seg lines in the blocker. Place a block with leap tape into the blocking arm and block the lens. Place the blocked lens into the block adapter and push the chuck key. Press the Start key to start the grinding cycle. The lens will be perfectly ground to the prescription, and we are ready for the next lens. For our next example, we will grind a progressive lens. Trace the frame as previously indicated. Press Data Set and the frame shape will appear on the display screen. We will enter the patient's distance PD into the PD field. The LE9000 usually subtracts the patient's pupillary distance from the frame's pupillary distance and divides the difference by 2 to get the correct optical center inset. This method will give you equal insets between the left and right eye. In addition to this, you can independently set the left and right eye with a monocular PD option. Press the Select key. The label on the field will change from PD to half PD, and the value in the field will change to reflect the patient's half pupillary distance. You may change this value by using the plus and minus keys on the control panel. We'll also need to set the height of the fitting cross. Now press the down arrow keys to highlight the height field, but this time enter the patient's height. Make sure the layout method is set to ACT or active. We set the lens frame material and grinding mode that is correct for the lens frame, bevel location, and right lens. Block the lens by aligning the fitting cross or major focal point with the center of the blocker, and block the lens. Place the blocked lens into the block adapter of the grinding chamber and push the chuck key. Press the start key to start the cycle. The progressive lens will be perfectly ground to that prescription. For our final example, we will grind an executive bifocal. Trace the frame as previously indicated. Press Data Set, and the frame shape will appear on the display screen. Enter the patient's distance PD into the PD field. With the vertical decentration set to the BT, enter the patient's seg height. Select BF Bifocal Layout Method. Set the lens frame material and grinding mode to EX. Spot the distance optical center with the lensometer. With a marking pen, make a new reference mark directly below the optical center on the seg line. Using this new reference mark, block the lens 5 mm in and 5 mm down. Place the blocked lens into the grinding chamber and push the chuck key. Push the start key to start the cycle. The executive lens will be perfectly ground to that prescription.